Hello. So in this video, I'm going to be explaining probability and understanding how to think about the outcome of an event or the outcomes of events with probability, right? So think about your traditional coin flipping exercises or drawing a card from a stack of 52, like a playing card deck, or tossing a dice, right? This framework and idea could be applied to anything with probability, from trading stocks and options, though I must warn you that the probability associated with options and stocks are not clearly defined like they are in our examples here, like rolling a dice. However, anything with probability and an outcome that is known and understood could be done using these techniques that I'm about to show you. So, imagine a game where you have a 10-sided die, 10-sided die, and it's an equal weighted die. So each of the sides has an equal opportunity of coming up. And in the game, if you roll an odd number, you have to pay the person, you have to pay the game manager, however number you rolled, whatever number you rolled. So if you roll a 1, you have to pay them $1. If you roll a 3, you have to pay them $3. If you roll a 5, you have to pay them $5. And then every even number you roll, you get paid that amount by the game manager. If you roll a 2, you get $2. If you roll a 4, you get $4. If you roll a 6, you get $6, and so on. All right. So let's we already know what's the chance of rolling each side, right? It's 10% for each one. You have a 10% chance of rolling a 10, a 10% chance of rolling a 9, so on and so forth, right? Even an equal number of chances to roll all of these, right? So because we have a 10% chance of rolling each one of them, we can kind of imagine that if we were to roll 10 times, right? Let's say we roll 10 times, and let's say every single time we rolled, we got a different number, which is actually probabilistically very unlikely to do. But let's just imagine, because there's 10% chance of all these 10 outcomes occurring. Let's just pretend that we rolled the dice 10 times and we got a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, right? Let's assume we got a unique number every single time, okay? Well, we know the payouts, right, for this because we've already discussed it. If you roll a 1, you're going to pay $1. If you roll a 2, you get $2, right? So let's say you roll this dice and it occurs in order. So you roll a 1, the first roll, you roll a 1, so you end up paying $1. Then the second roll, you roll a 2, and you end up getting $2. You roll a 3, you get $3. You roll a 4, you get $4, etc., right? So we can actually think about this in terms of rolls, right? After you roll your first roll, you are minus $1, right? However, after you roll your second roll, you got paid $2, but since you're already minus 1 from your previous, you actually ended up getting, you're now positive $1, right? So you had a minus $1 in your first roll, plus 2 on your second roll. That makes you as a net of plus 1. Minus 3, so you were positive $1, and then you get a minus 3, so now you're at negative 2. But you're at negative 2, now you get you roll a 4, so now you're at 2, so on and so forth, right? You can see how this plays out. Great. So after the end of the game, you're now left with $5. You've won $5 from the entire game. And remember, you rolled 10 times. So you won $5 after 10 rolls, which, if you think about it, is like winning 50 cents per roll, right? You won $5 after 10 rolls. That's 50 cents per roll. So this is the logic of how you can think about probability and payoffs, okay? Now let me show you the math of how to calculate this without having to do this weird type of scenario, okay? So, like we said, there's a 10% chance of each outcome happening. What we can do is we can times the outcome by the percentage, right? So we have negative 1 here is the outcome. It's the payout. We get -1. We lose $1 times 10% equals negative 0.1. 2 times 10% is going to be 0.2, and you get the idea here, right? It's just timesing by 10, 0.10, 0.1. And these are your expected or your estimated value of all of this, right? Times percentage. So then to get an understanding of what you're going to earn on a per roll, right? So we estimated how much each payout is from each roll. We need to understand what the value on your average roll is going to be. If you roll this dice in this game, in this specific game, right? On average, you're going to receive 50 cents. And we do that by adding up all these numbers here. We add them all up and we get 0.5. Use the sum function here. So every time we roll this dice, we're expected to win 50 cents. Now, of course, it won't play out like that in real life, right? First, you might roll a 7, so you might be down $7. Then you might roll a 2, so you're now down $5. And that's not the average of 0.5, right? But if you play this game infinite amount of times, heck, maybe 1,000 times, eventually you'll get an average of around 50 cents per roll. So the quick and easy way to calculate probability and outcomes of events like this, right, is you take the outcome, in this case the payout, you times it by the percentage chance of it occurring, and then you take all those numbers, right, and then you sum them up and you get this number here. You can do this with all sorts of stuff. You could have even odd number stuff, right? So say we have a 3-sided dice, okay, and say you win $10 if it rolls a 1, but you lose $5 if it rolls a 2 and $5 if it rolls a 3, right? But let's say the person who's playing this game was cheating, okay? Let's say that the percentage chance of rolling a 1 wasn't the 0.33333 that we'd expect. Let's say it was actually 0.2. And let's say the other ones had a 0.4 percentage chance, right? Not 0.4 percentage, but let's say 40% chance, okay? Like this. So now we can calculate the odds, calculate the payout of this game. So again, we times the 10 by 20%, then we times the minus 5 by 40%, minus 5 by 40%, and then we sum all those up. Of course, you can do this in one cell if you want, but I'm doing it out to explain. So on average, your roll here is your average roll is going to lose you $2 in this game, right? And it's because they're using an unfair dice. Unfair dice. Okay, you can't even see that. My bad. Wow, I don't know how to do this. Okay, cool. So yeah, so that's how you solve this. Hope that was helpful.